So, Assalamu alaikum, marhaba. I'm Adam Mohammad, civil engineer. I think most of you already attended my first session, so no need to introduce myself. This session is going to be about road rehabilitation, right? Not always we have a green field or existing conditions that we directly start the design process of a road. Sometimes we have an existing road, an old one, and maybe we just need to mill it or remove some layers of it, put some new layers, and make it new. So this session talks about kind of the new workflow that we have at Autodesk, using tools like Recap, InfraWorks, and Civil 3D, and how we can simplify the process of road rehabilitation or the design of existing roads, improving them, by using these three tools, and some of the new capabilities that were introduced this year and early last year. Okay? So we all know that the construction industry and specifically infrastructure projects has very limited budgets, and contractors also are competing on very tight margins. So we need to have some efficient workflows in order to save time and save resources. And this is where these tools come into the picture. We also need, whenever we want to, for example, do some road rehabilitation, we need to be very efficient in the construction process, not only the design process. Build it with speed. And definitely, that design of the road rehabilitation has to be according to standards. Same like we design a new road from scratch using the AASHTO standard, for instance, we have to apply a certain standard to rehabilitate an existing road. So designers have to prioritize multiple alternatives sometimes, and these alternatives have to be cost-effective. They also have to come up with creative solutions and save on time. But what we currently see in the industry, specifically with infrastructure, that most of our designers are using AutoCAD and sometimes Excel. Some of them use Civil 3D, but unfortunately not to the fullest potential. So they use Civil 3D in some areas, but then they go back to AutoCAD to do some certain design processes. So we're going to show now how we can move from this AutoCAD and Excel workflow for the road rehabilitation with BIM using InfraWorks, Recap, and Civil. Before I start, so how many of you now already know about InfraWorks, please? Almost 50, okay. Okay, InfraWorks is a BIM-enabled tool that basically helps the designers during the planning, preliminary design, up till early detailed design phase. And as we've seen from the previous videos, it's very visual. So it has a very simple user interface where we can design roads, bridges, rail alignments, for those of you who attended my previous section. And not only visualize or create, also be able to analyze those models that we'll create, evaluate sometimes the cost, specifically for roads, and communicate that model throughout. So allows us to create more than one single alternative, very easy, very quickly. Because I promised you I'm going to show you InfraWorks for those of you who don't know it, I have a sample of an InfraWorks model. So the base actually, once we open InfraWorks and we fire it up, we have a very simple home screen. Okay, I think it's working. But as you can see, very simple icons. Once you click on one, relevant ones update. Okay, so once you click on InfraWorks, once you open it, this is the user interface. Also very visual. So any model that you create will have like a thumbnail, a picture of how the model looked like. You will be able to see what is the name, when it was updated, if it's residing on your machine, maybe on a local server, or maybe you have uploaded it to the cloud. Maybe you have different teams working in different offices in Turkey and you want to connect them together. So that's also possible. Inside this InfraWorks, there's a very powerful feature called Model Builder. So what Model Builder does, okay, let me move quickly to Model Builder. So Model Builder inside of InfraWorks, as you can see from the video, allows you to specify a city, and you can try it for Istanbul. It's free, by the way. So you type in Istanbul, in this case it's Cape Town, the capital of South Africa. It will zoom in to that area of interest. You specify an area of up to 200 square kilometers. That's the maximum accessible. And then you specify a name for the project. Could be new road network, or new bridge, or new rail track, whatever the case. And you share it with your team. You hit the create button, and within minutes, the model will be created in the cloud. You will be notified by email. You will have this thumbnail in your InfraWorks. Once you click on that thumbnail, the model will start to download. So it's a one-time process. You do it, you download the model, and the model will be on your PC. The end result will be something like this. Definitely, this varies from city to city. So in this case, we have the Table Mountains of South Africa, of Cape Town. You will have the terrain. You have the satellite image coming from Bing Maps. You have all the roads, the buildings, the structures coming from OpenStreetMap, also available in there. Now, what's the accuracy of that model is not very accurate, but it's good to start the project if we don't have any other data coming from the surveying or coming from the client. But what's also good about it is that we can basically update the data. So if I have any file format, any type of data that's a 3D model, AutoCAD, DWG, 2D, or 3D, I have point cloud, like laser scanning. I have Revit models. I have shape files from Esri, even DGN MicroStation, any type of data basically. I can bring it into InfraWorks and update that BIM model that I've created using the model builder. So if I have, for instance, as a road designer, I need to have the most accurate surface that I can get my hands on. So if I have that surface, I can bring that surface in and update the model and start my design process. A sample model that I've created using Model Builder, the same feature over here, is this model of Dubai. So as you can see, this is 200 square kilometers, but if you have more data, 500, 1,000, 2,000 square kilometers, you can bring it in very quickly to InfraWorks. And you can manage the data from the data sources panel. So here where you can basically access, modify, update any of the data sources. I can zoom in to the objects, I can rotate, I can navigate very quickly. Because again, this is not an AutoCAD-based technology, this is a very quick, very robust technology. And what it allows me to do is basically not only design roads or bridges or anything, I can design a complete project. So even architects can basically leverage InfraWorks. In this case, just to give you a quick example, just a sample project that I've created in Dubai. I brought some residential buildings created in Revit, an office building created in Revit, 3ds Max objects, those covers or the canopies of the parking. I modified the terrain in Civil 3D. I created the parking bays or parking layout using vehicle tracking inside of Civil 3D. I brought all that information in and I've put it all together in InfraWorks. Now for us as civil engineers working on roads, also in a couple of minutes I'm going to show you some examples. So I'm just going to save this as a bookmark so that we don't lose anything. Okay, I think it's saved. Okay, it took two. Fine. We go to the road module, and remember when I talked about the component roads, we pick a component road from here, and this is where we're going to design a road in different ways, either by PI or element-based. It doesn't matter for me. I'm working on the AASHTO metric 2011. If we have the Turkish standard for road design, I can import it in InfraWorks library and use it as well. What type of road? Local, collector, arterial, and that will definitely change the design speed. Let me pick a certain cross-section. Think of it as an assembly. I'll pick something that has some road components, like this one. And once I move into the model, I can basically sketch and get an idea about the length, about the curvature. If I'm not an engineer and I don't know about the code and I try to violate the code, same like we have in Civil 3D, those triangles on the profile, for instance, it's going to give me the same thing over here. We create the curves, double click. In a matter of seconds, I was able to create a road with all of the road components. And that road is not just a simple representation, it's basically a BIM model. So once I click that road, I have all the parameters of that road. I can turn on or off the super elevation, I can change the type of material for the grading, I can calculate the quantities. Let's just very quickly go pick another road. And as a designer, I have this situation. So then the software will analyze, will create an intersection for me very quickly. And by the way, this is not just road alignment and profile, this is a 3D corridor. So once I open this inside of Civil, if you have 2019 Civil 3D and 2019 release of InfraWorks, this will come as a complete 3D corridor and you will have the sub-assembly specified over there. Again, this is not a dummy object. If I pick the intersection as an engineer, maybe I need to change the curve return. And I have a specific radius as 12. The 3D model altogether updates. What if I'm working in an airport or a seaport or a facility that needs bigger vehicles, not a small light vehicle, but a truck or a trailer? So once I click on that truck or trailer, based on the turning radius of that truck or trailer, the 3D model will update. So let's suppose I save this as final presentation. As a designer, I have another option. Let's call it Great Istanbul. And then, that's option one. It's already saved in the system. I click on it, and I ask the software, please, I'm planning to have a roundabout instead. Same story. It reads from the available engineering standards, and these are mostly US driven. So this is the Federal Highway Association in the US. Let's suppose I have a limited space. Here, I can pick, for example, mini roundabout, and then everything will update. If I have bigger space, I can, let's take triple lane, everything will update, same story. And definitely I have all the required gizmos to change the roundabout, like I've done with the intersection. If I look in profile view, it's different than looking from plan. Let's suppose I want to have this elevated, because maybe the drainage is going from that side, and we have the lowest point on that side for the drainage network. Okay, that's nice, that's cool, but what if I want to have a quick update about the materials required? So I just click on that road, and again, I'm using component roads, not planning roads. We go to this cut and fill. Once we click on the cut and fill, it asks me, do you want to calculate for the whole length of the road? I say yes. And then I hit this button. And there you go. All the quantities for cut and fill and the net fill are calculated. If I hit the calculator button, it's going to show me all the ingredients that make up this road, including the street lighting poles estimate of maybe, I can't see it, it's like 52, which then I can generate to Excel to a cost report. Now some of you will ask me, well, this is fine, this is only conceptual, but as a designer, more than just having the annotations, I would like to modify it in a profile view. That's also possible. So same like we do in Civil, we have those points, we can add some more, we can elevate some of those points, and once I move my mouse to the 3D model representation, you will see that I've modified that area over there. Let me just keep it as is and show you very quickly also the bridge design. We can't cover everything today, but let me pick a steel plate girder bridge, and as per my design, I want to have a bridge that goes from this station to this station. Let's make it a bigger bridge. Once I hit the double click, InfraWorks will read how many lanes, what is the expected live load, dead load, and then we'll calculate the structural components required to make that bridge, and it's gonna give me an option of a bridge with all of the girders, with the piers, the bearings, And even if I go underneath, I'm going to find the foundation, the piles, and on the side, we have the abutments. All of these components can be modified as per my requirements, as you can see here, the parameters. And even if I have a library of different components, which, by the way, we create an inventor. So for those of you who use right now the parts builder with Civil 3D, the current workflow or direction with Autodesk is we use another software called Autodesk Inventor. We create all these parametric parts, we import them into InfraWorks or Civil, and then we can build our parametric models. Same story, like with the roads. If I go a little bit here, I pick on the bridge, I can calculate quantities, concrete and steel. And if I am a road designer, but I also want to send something to Revit, I can just click this, create a new model, and all of what I've made in terms of bridge will go as a bridge Revit model into Revit, so that the structural design can go from there onwards. Okay? So this is just a quick overview about InfraWorks and the model builder. Let's go back to what I was planning to cover today. Now, mostly when I present on InfraWorks everywhere, I get asked this question: is InfraWorks, because it's highly developed, it has two functionalities, is InfraWorks going to replace Civil 3D anytime soon? And the answer is no, because InfraWorks, as you've seen, very good, very visual, but we cannot produce any construction documents. We cannot create the plan or the sheets, profiles, and cross-sections. And this is where Civil 3D still is the right tool to do that, to do the detailed design, to get the final quantities, the accurate final quantities, and definitely create all those required sheets for the construction process. Now, the power of InfraWorks and Civil 3D is that they read from different file formats. So basically, any file format that you can think of, almost, you can bring it into Civil, and there's a huge integration between InfraWorks and Civil 3D. You can open an InfraWorks model in Civil, and you can send the Civil model into InfraWorks as well. And recap, how many of you know about Autodesk Recap, please? 1, 2, 3. Okay. Okay. So nowadays, instead of having the traditional workflow, as I mentioned in my previous session, having surveyors on site, putting a total station, and having another one on the other side, carrying like a pole or a column, and they start to take points, just random points, the new trend is using laser scanning. And this laser scanning is very powerful. So it can be taken by a laser scanner that is fixed, or we can put it on a vehicle that goes around the site and scans everything, or even we can fly a drone, and that drone has a camera, takes pictures, and from those pictures we create a 3D model. That's very quickly what point clouds or laser scanning is. And let me just show it to you. So whenever we talk about reality capture, sorry, the title is not shown. I wanted to talk about reality capture. So any act, any event of capturing existing conditions is called reality capture. Reality capture is two ways. Either the laser scanning, which is using these scanners, or as I mentioned, photogrammetry. We send a drone with a DSLR type camera to take those pictures, and from those we can create 3D models. Now, think of the laser scanner. Like we have computers coming from different vendors, different companies, those scanners come from different companies. So we have Leica, we have Topcon, we have Faro, we have Trimble, different manufacturers. Each one of those manufacturers with those devices generates a file format that's specific to them. What Autodesk did, they've created Recap, Autodesk Recap. This is the tool that you can see it over here in the middle, okay? To basically read file formats from different vendors or coming from different ways, and this software translates this data into a file format that Revit, AutoCAD, Civil 3D, InfraWorks, and others can read. So Autodesk Recap is the middleman, is the translator between the hardware and the software tools available out there and the Autodesk design tools. This is the major functionality of Recap. Now, within Recap, not just for point clouds, As I mentioned, we talk about laser scan, we talk about also photogrammetry. So we have something called Autodesk Recap Photo. So from within Recap, we can bring those pictures that we take using the drone, but they have to be overlapping pictures, so there is some intersection between them. These pictures can be up to 1,000 pictures taken. They're sent to the cloud, and then within a few hours to 1 day, you receive a 3D model of whatever you've captured on site. Now, the 3D model is good if you take the picture in the right way, in the right manner. So there are many requirements on how to position the camera, what is the percentage overlap, the weather conditions, etc., etc. But once you get that model, you're able to georeference it, put the X, Y, and Z coordinates, because what you actually get is a 3D mesh. So this is a point cloud. Or you get a 3D mesh, as you can see. It's not a BIM model, but we can transfer it into a BIM model. And then from there onwards, you can do some editing, you can bring the data into Civil 3D. So this is, for example, a case study or a project where a quarry site, a site where the excavate material was taken using the drone, and every week the contractor used to fly the drone, capture the data, create a surface, and compare week 1 to week 2, surface 1 minus surface 2 from week 2 from surface 3 to check what is the progress on site. And definitely we can bring the same model into InfraWorks or even Revit or AutoCAD. A sample example of the laser scan, of these laser scans that, as I said, might be mobile on a vehicle or static, is the bridge over here. So imagine if we want to capture all the details of this bridge using the traditional techniques, just having a total station and a prism over there and picking points. We're getting billions of points, literally millions or billions of points that are georeferenced. They give us the shape of the object, and they are to scale. So I can measure, I can check if that bridge, for example, I want to widen it, will hit the rail track or not. And all of that is being done in a matter of minutes, not hours, not days. So I hope now you have a clear understanding of the power of InfraWorks and the power of Recap. So this is again another chart which highlights the link between InfraWorks and Civil 3D. What do we do in InfraWorks? Point cloud extraction, earthworks, road drainage and bridge design, and then quantities, the drainage design, the final road design, and other things are being done in Civil. We also use Revit for the bridge and the tunnel detailing, because in InfraWorks, we create those components or those objects, and then we can either move them to Civil or Revit depending on the object itself. If it's a structural, like a bridge or tunnel, it goes to Revit directly, retaining wall and quantities as well. And what are the file formats that basically we can push from one software to the other? So how we can connect a Civil 3D model to InfraWorks? We can export a shapefile, SDF file, IMX, or DWG. And if we have, for example, an InfraWorks model, we created something conceptual, we want to move it to Civil, we have a shapefile, CSV or RCS, sorry, IMX or the SQLite. Each one of those file formats gives me privilege or gives me some opportunities. Okay. So let's start with the existing conditions. As I mentioned, now that we know about the way of measuring things, what the contractors do on site or the consultants, they go with the classical survey, they send a crew to the site, right? Imagine if it's a road or a network of roads that is tens of kilometers. How much time would it take and how many people will have to go and take points along the way on each side of the road? So this is what they do. They send surveyors on the site, and then the surveyor basically generates points, then surface, could be the surveyor or the designer, and then they feed it into Civil 3D. And then they can leverage the Civil 3D platform for other uses. The major three drawbacks or challenges are these. First of all, it takes a lot of time. So for a short road, that's fine. Maybe a day or two. But for a long one, no. It's also risky. So think of those highways, the big highways, 3, 4, 5 lanes where you have high vehicles moving. Would you need to send the crew over there to take points while the cars are moving fast? It's very risky. It's life-threatening. So this is where we use the point cloud or laser scanning instead. And same in regards to the data. Sorry, this one should be data captured in the. Data capture is limited because we're picking just few points instead of billion points. The point cloud workflow, the laser scan workflow, allows us to do as such. So remember when I told you about the different providers or manufacturers of laser scans? It could be Faro, Leica, I can't keep up with them, Topcon, and many others without forgetting anyone. So they export the data from the laser scanner in file formats. That data, we use recap, Autodesk recap, to read it, to register it, because think of 10-kilometer road. They will take maybe one scan over here, another scan over there, another scan after 1 kilometer, and they need to bring all this data together, basically like stitching. So this is where recap does the trick. Once we process this data in recap, recap sends file formats as RCP and RCS. Basically, they're the same thing. The only difference is that RCS is the actual point cloud, and the RCP stands for Reality Capture Project. So as I mentioned, if you have 1, 2, 3, 4, 5 locations, you will have 3, 4, 5 RCS, but you will have one RCP file managing those files. You open this file or project inside of InfraWorks, and inside of InfraWorks, you're going to see the powers we have in terms of analyzing what is this point cloud and how we can extract data from it. So this is where we get the terrain, we get the surface, the complete surface. We generate feature lines, and these two components, we send them out to Civil 3D to start the road rehabilitation design. This process, so from here to here, might take 2 to 3 hours max, even with a huge data set. What usually happens on site for a 10-kilometer road might take a week or 2. So imagine the time saving we have just from this day till the moment we push all that data to Civil 3D. Not only time saving, but also quality-wise. You're going to see later on how we can save on the quality. So to summarize, saves a lot of time. It's easy to conduct on site. It's safe because no people are walking on the site in front of the traffic. And actually, and that's really surprising, even if you put the laser scanner on a pickup or on a truck, and that truck is scanning the site at a speed of 80, 90 kilometers per hour, you will get extremely accurate results. And definitely billions of captured points, not just 100, 10,000, etc. So for example, I'm going to show you a real case study from UK, where the guys from Autodesk with other guys from Faro, one of the laser scanner providers, captured 35 miles, approximately 35 miles, at 9 a.m. in the morning at a speed over 60 kilometers per hour. And they've done it in a matter of minutes instead of hours, because they went all the way like this, all the way opposite direction, and they got all the data in. Definitely, some consultants or some even contractors would like to merge the two workflows together. They will have some sort of point cloud with some sort of classical survey. That's also possible, depending on the use case. But point cloud or laser scanning is the way forward in terms of taking the existing conditions. And again, the file types and how do we push the models from the classical survey to, even just by using Civil 3D alone, instead of the plain AutoCAD saves a lot. I don't know how people here in Turkey do it, but once the surveyor takes the normal points on site, if they bring them to AutoCAD, they have to do a lot of manual work to analyze the points and identify them as edge of curb or trees, etc. Inside of Civil 3D, so here, even if we get those points, we can directly assign them blocks or styles or attributes. So again, Civil 3D on its own, even using the traditional workflow, saves a lot of time. We talked about laser scanning, so now we can skip it. Okay, so it's an example of the project I told you about. It was done north of Britain on a highway called the M62 highway. Some guys from Autodesk, some guys from Faro, they had a mobile scanner on a pickup and they scanned the site. They brought all this data into Recap. So this data was fed into Recap. They specified the coordinate system because as civil engineers we need to have the data sitting or residing in a coordinate system, otherwise it's of no use. We specify some parameters and then we can also specify some targets. So maybe the data was captured in one coordinate system, but we need to transfer it to the Turkish or Istanbul coordinate system. So the software on its own will make the translation. So we'll check each and every point, we'll calculate its X, Y, and Z in the old coordinate system, and then we'll calculate the X, Y, and Z according to the Istanbul coordinate system. And we'll do the translation for all of the billion points. Not only that, it will also take into account the different scans done at different intervals, and we'll put all this data together, we call stitching. So it will stitch data together to get what we have in that model. Definitely this is just one sample, one stretch of the road. But as you can see, we have a lot more details than just by the normal way of picking certain points. So this is very quickly a recap. And definitely if the designer wants to trim or filter some of the noise, so you will have some points sitting in the cloud, could be some dust. Maybe there is a dust storm and the laser scanner picked the dust in the air because basically the laser scanner sent a beam, this dust particle reflected it, so it created a point in the model. So we can, inside of Recap, filter out or remove some of the noise in the model very quickly. Now, we're done from capturing the existing conditions in Recap or the laser scanner. Now we did the translation, we did the coordinate system thing or the stitching. Now we just want to import the point cloud. So inside of InfraWorks, we specify what is the coordinate system, Istanbul XYZ coordinate system. We go to the data set. We pick the RCP file or RCS file, regardless, depending if we have one or more. So here we have an RCP file connecting more than one. The M62, I guess, yeah, M62. And then in a matter of minutes, we're going to bring that data into InfraWorks. By the way, that data is huge. That point cloud is 72 gigabytes. Not megabytes, 72 gigabytes. Billions of points. And InfraWorks is so fast in reading this data and understanding it that this video was recorded by my colleague. His name is Peter. He was actually working on this project. He did not, stop the video recording and he said, no, I wait for it. He waited all the way. It took a couple of minutes until that data source was imported, and then he did the configuration. 72 gigabytes of data, billions of points. And once that data is brought into the model, all what we need to do is just minor configuration. For those of you who work with InfraWorks know that if I'm bringing a Revit model, I need to tell InfraWorks this is a building. If I'm bringing a civil model, I need to tell it this is an alignment, for instance. And then you will see how that data is being translated and shown in my InfraWorks model. So what do we see here? Remember when I showed you the model builder? And I said this is just the starting point if we don't have any data from the client. What you see in the background is everything that we got from the model builder. And then we went on site, captured the data using laser scan, and then we updated the model with the laser scan. If you go online and check more about laser scans, you will find that some of those laser scans or points have colors, especially for buildings. What laser scans do, other than sending a laser beam and capturing the exact location of every point, X, Y, and Z, they take actually pictures, 360-degree pictures, and they analyze the picture, they take every pixel, the color from that pixel and they put it on the point cloud. But if we do that, it's going to take a lot of time, and we as civil engineers don't need it. That's why, for this purpose, we only brought in the point clouds as X, Y, and Z, and definitely one additional parameter called intensity, which we're going to use later for classification. But we don't need high-end visualization of the point cloud. So I covered this, you know, about Model Builder and how InfraWorks can read data. Okay, so this is again the same point cloud, which extends for tens of. Okay, did you notice one thing? So when we went underneath the ground, we found that the existing condition is actually under the surface which we got from Model Builder. That's why we always say Model Builder is not very accurate. But we will see what's going to happen in a minute. So we have all that road, we have all the trees around it. Look what's going to happen here. So point cloud terrain, I will ask the software to analyze these billions of points, 72 gigabyte data, and according to a certain filtering process, I want it too accurate, I want it medium accuracy, etc. I will let InfraWorks analyze the whole thing. And this, by the way, takes about an hour or two, because, again, it's billions of points. Once it's done, this is the end result. Before I go into this, let me show you one simple thing here. I don't know if you can see it, but we have vehicles. Can you see those objects over there? Remember, the capturing was taken when the vehicle was moving at 60, 70 kilometers per hour on a road full with traffic. So the data has a lot of noise. After we asked InfraWorks to analyze that data, look at these points. So flush with the road. It only picked the points that are relevant to the surface and created a surface model updating the existing one. So the surface coming from Model Builder actually was updated to pick the exact surface of the point cloud. And see how accurate it is? It's picking up the road marking, etc., etc. So you can go along the way to check tens of kilometers from that point cloud. As you can see, it takes super elevation, the exact surface of that road. Now, let's do some more interesting stuff. So, not just by getting the surface automatically from point clouds, let's do some more analysis. So, we as civil engineers, we would like to extract linear features. All what we have to do, take a line, pick a point over here, pick another point over there, along the path, hit enter, and the software automatically will analyze the whole model of the point cloud and will generate a feature line, 3D feature line, with all of the points across the center alignment of that road. There is no need for the civil engineer anymore to bring that data from the side point by point and pick them one by one. And by the way, this feature line that was detected extends 9 kilometers. Imagine if you want to do this one by one. And it's so accurate because it's based on billions of points. We can do it for the center line, we can do it for the curb, we can do it for the road marking if we have any road marking in between, you name it. Just a few clicks and the software will automate the process. This is how mega infrastructure projects are being done nowadays. Point clouds into InfraWorks, generate the terrain, and then feature classes or feature layers. So as you can see, all the way. If I want, as a designer, to make a modification, I can go into one of the points and modify it sideways or even in terms of elevation. So this is the end result. These lines will help me do what in civil? Create a cross-section, then generate a corridor. Because again, this is an existing road that we would like to rehabilitate. Another thing, because sometimes if we're taking the edge of curb and it's not very accurate, right? Sometimes at the edge of curb you have dust or sand or even some plants growing. We have a tool that is the cross-section viewer inside of InfraWorks. So if we don't want to do it in plan, we can do it in cross-section. We take those points, we move to another cross-section, then we go from one cross-section to the other, to the other, to the other. And automatically the software will create the feature line in 3D. As you can see, this is the center line, the edge of curve, we might have the top of curve. So we're transforming, basically, the static model coming from the site into a BIM intelligent model, where we have intelligent objects that can be used in Civil 3D for the BIM design or BIM detailed design process. Another thing, so we generated the surface, we created the feature lines automatically, we're able to check the cross sections, we can generate transverse lines, meaning I want to create like cross sections or lines across the length of the road. And I can specify at what distance, taking into the cross section in mind, and to what file format I want to export it. Because I would like to take all this data and send it to Civil 3D, from which I will create the existing surface of the road, and on which I will start my new corridor model. So as you can see, we're specifying the data one by one, etc. And then we move that data from InfraWorks to Civil 3D in any file format that we like, and we get all this data in Civil 3D as feature lines or other objects. This is an example of surface generation from those data that we've brought from InfraWorks. So since we already have the alignment, and actually we have the surface coming from InfraWorks, or even just the feature lines, from those lines we're able to generate the 3D surface of the civil. This is the old way of doing it. A little bit manual, but at least it's based on accurate data. So we generate the surface, triangulation, and then using some functionality like break lines or boundaries, we trim, we modify to get the final surface of the existing corridor. On which now we can check if we want to do any cut or fill and lay any new layers of asphalt. Not only that, InfraWorks is able to detect from the same point cloud, if it detects any object that is a tree or a signboard, it will give me from within the Autodesk library an object, a 3D object, that I can just drag and drop in that place of the 3D object. So this is what we call AI, artificial intelligence. Being able to recognize objects like these and replace them with 3D objects in the model very quickly. Why do we need this? Because if we have, again, something that's existing, we want to widen it and improve it, we don't want the designer to put them one by one and waste his time. We let the software do it automatically, and then the same thing like we've done with the feature lines, we extract that data in a shapefile or CSV, we import it into Civil 3D, and based on some map 3D functionality, we can assign title blocks or styles to those objects. So the end result will be, once we're checking the model in 3D, we have the objects showing, and even they are showing in the cross-section or the plan view of those models, of the existing ones. Again, automation, saving time, saving resources. So now let's move to the actual thing of the road rehabilitation. So to do any road corridor for the new road, we need definitely an alignment, a profile, a cross-section, or an assembly, and then from which we can generate a corridor, simply. So inside of Civil, there are many ways of creating an alignment. We can design it automatically ourselves. We can upgrade an existing polyline or do a best fit alignment. Depending on the case, we use one of which. Now in our Middle East region, most probably we're going to use the best fit alignment, because We rarely have medians in the middle. We have just New Jersey barriers or features, so we can pick the right side of the road, the left side of the road, and automatically Civil 3D will create a corridor with the center alignment at the center of the roadway. But that's, again, depending on the case study. So we use all the functionality of Civil. The surface, we have the profile, we have the assembly, and from which we create a corridor inside of Civil 3D. Now, inside Civil 3D, there are many assemblies that we can use to do the road rehabilitation. These are the old ones we used to have. They are cumbersome, they take a lot of time. So what Autodesk did, without wasting your time, and instead of going into the sub-assembly composer and doing things yourself and messing around, is basically adding this functionality since 2018. It's called the Rehab Corridor. So we click on that, and then we have specific sub-assemblies to do the rehabilitation of the corridor that can do overlay and leveling, etc., etc. So there are three major ones. The first one is overlay level crown. So in case we have the existing surface, we specify this existing surface, we just level it, and we add layers on top. If this is the case, we use this sub-assembly. No need to program anything in the sub-assembly composer. All of these three sub-assemblies are highly documented inside of Civil 3D, so there is no need for you to maybe learn a lot about them just by reading the documentation. The other one is overlay, mill, and crown. So here we specify the milling depth, we excavate this, and then we overlay the material on top. Or else, the more, I would say, detailed way of doing it is basically we have an overlay, we have milling, and we have leveling. So we excavate this area, we do some leveling, and then we do some, milling, leveling, and then laying on top. This is how the rehab corridor will be activated inside of Civil. So we go to the corridor, we go to the rehab corridor. Sorry, I'm running a bit quick because we're running out of time. We specify the alignment from which we've taken maybe from the surface, and then what will this do is basically take us to the rehab editor. It's like a new way of showing things. We have the profile, we have the plan, and this is where we modify parametrically in terms of numbers how we would like to have our rehab corridor. And then once it's generated, we will have any idea about any problems, same like with design checks in Civil, if we're violating any standards, so that the designer will know where to make any modification. Finalize the design, generate, for example, you can have these tables. These are the red areas where you have to make some modifications or corrections. You can specify a color set, schema, generate the documentation required, cross-sections, etc., for the construction process. So very easy to use. The only thing that designers need to take care of with this workflow is just to check for that. Sometimes, because it's based on cross-sections, and we're doing it differently, there are some certain bumps in the profile. So this is where it's a good practice to put some annotation, conditional annotation, so if the grade or slope is less or more a certain criteria, it will highlight it for you, and then you can make those tweaks automatically to save on time. Hopefully in the future, Autodesk will make this process also automated. With a single click of a button, it will be automated altogether. And then you can generate tables, cross-sections, to check that your design meets the standards. Definitely other tables as well. The last thing that I will cover in 2 minutes, think of capturing the existing conditions, designing the road rehabilitation. What about moving into construction? So that road is already populated with traffic. We need to do some lane closure, close one lane, and then open maybe a traffic diversion. This is why we need some traffic analysis. Inside of InfraWorks, that same model that we've created, we can bring the model into InfraWorks and do simulation of the traffic. And by the way, this is almost free of charge. Instead of our customers having Vism or the other tools which cost a lot of money, this is almost free. It takes like a couple of cloud credits, few dollars, to do all the simulation and analysis and show you that if you need, for example, to add one additional lane, how would that affect the level of service inside of the InfraWorks platform. So also, we're moving from capturing the data, designing the road, and then into construction. Then you can generate, different scenarios. This is how the things are. This is when we close one lane for rehabilitation, we close the other lane, and then generate analysis and tables and views. Traffic simulation is based on data. So you input the data in, which you currently get from the municipality or the governmental authority. You specify constraints. And again, you will see these animations in 3D. This is just the traffic analyst panel where all of the traffic simulation parameters go in. So we're almost done. And there you go. So you can analyze the traffic around that area where you have the road rehabilitation. It could be to 50, 60, 70 intersections or roundabouts. This is covered. That's it basically. So I think we're on time. Any questions about road rehabilitation? Okay. So what I want you to take from this session is that the way of capturing data is changing. Now people are using point clouds, laser scans to get a lot of data and analyze it. The way of analyzing this data is changing with InfraWorks, automation, artificial intelligence, detecting the surface, the 3D objects, and the alignments. We move all that data to civil, where we basically create the surface and the new corridor for the road that we would like to maintain or rehabilitate. And then we can move back into InfraWorks if we need to do any traffic simulation to check if the construction process will not affect the existing traffic and cause a lot of delays. That's basically the workflow that we have in hand. If you do any road rehabilitation and you want to leverage those tools inside of Civil 3D, you have to have the latest Civil 3D 2019 to have those sub-assemblies that I talked about. Okay? Any questions, comments? No? Okay. If you have any questions,